Alright, what we are going to do today, hold near the is to heat this slowly, heat the hydrated blue copper sulfate slowly, and see what happens to the color change, because the color change can lead to a conclusion that there is a chemical change. Okay, so we're going to heat this slowly and let's see the color changes. Okay. Yeah, very slowly. Okay, yeah. Can you heat it? Yeah. Ah! Yes, keep on stirring. The hydrated copper sulfate crystal is blue because it has got water of crystallization. Okay, so if you heat it slowly, it turns a little bit whitish, right?
Yeah.
Can you see? So it's turning white. Keep on stirring. Okay. Turn it around. No, hold this. Okay, keep on stirring. Don't press that. Yeah. Okay, so is it whitish? No. Well, it's beginning to melt. Let's heat the water of crystallization away. Let's not let it go back to the test tube. Don't go back to the test tube. Yeah. Keep on stirring.
This part's like
Yeah.
stuck.
It's
this
stuck.
part's white.
Never mind. Let it get stuck. It's okay. Let me try. Okay, let's drive the water away. And now the water go back to the test tube. Okay, so it turns a little bit white, but you also notice that if I heat it strongly, this part turns what? It turns what does it turn into?
Green.
No, not green. Okay, I think it. What does it turn into? Turns what?
Solid.
Does it turn? Oh,
It's white and brown.
it turns brown, but before it turns brown, it turns what? Before it turns brown, it turns
White.
white, it turns brown, but you don't see black, do you?
Not really.
Let's try and see. Actually, you should see black first. Okay, let's look at this portion. Does it turn black? No. No. By right, it should turn black first before it turns brown. Okay, we hold this. Let's take another one. This one. Hold this. Let's take this one. This got white and brown. Huh? These are white and brown. Let's see whether we can get black. It's not hot enough. No more gas. Okay, never mind. We might be able to get some black. There you are. Is it black?
Yeah.
Yeah, black, huh? We are able to get black from blue to white to black, and then from black to brown, right? Yeah. So there are blue, white, black, and brown. So many colors. Okay. Now, what is actually happening is there is a lot of decomposition taking place. Okay. So now we have got all the colors changes that are trapped in one test tube. Let's make it very brown and see. Let's make it very brown. You can put that inside here. Yeah. Okay. What do you think the black substance is and the brown substance is? This is black. This is black. What do you think the black is and the brown is and the white is?
The white is dehydrated copper to
The white is what? Well, we don't call it dehydrated, we call it anhydrous copper 2 sulfate.
Yeah.
Okay? Copper 2 sulfate. And the black is? What do you think the black is? The black is?
copper sulfate.
No. The black is an oxide. That is copper 2 oxide. Yeah? Copper 2 oxide. And actually the brown could be two things. The brown could be copper 1 oxide. It's brown. And it also can be copper. Just think about it, and it is possible that the brown, you can actually get copper from heating. Okay? Anyway, this is what we get. Okay? Now, if we switch off the flame first, where's your pen? Bring your pen, please. Yeah. Okay. This is a pencil pen. Okay. So I have got blue copper sulfate crystal with the water of crystallization. This one is blue. Right? This first one is blue. Then when it went to white, then it is copper sulfate without the water of crystallization. That's why. And as we know, that is called anhydrous copper sulfate. And this blue is hydrated copper sulfate with the water of crystallization, which is 0.5H2O. Then we heat further, it goes to black. And the black is copper 2 oxide, CuO. And then we heat further, it goes to brown. And the brown could be copper 1 oxide, like that. CuO2O. CuO2O is copper 1. The reason why it's copper 1 is this is 1 plus and this is 2 minus. So the copper 1 oxide is brown. For all you know, that brown could also be copper. It could also be copper. It can decompose to copper and oxygen. How do we know? Because we have heated mercury 2 oxide, right? And mercury 2 oxide decomposes to mercury liquid and oxygen. So copper is capable of doing that because it's way down in the metal reactivity series and you would like to go back to the metallic state. Like mercury oxide, mercury 2 oxide likes to go back to the metallic state of mercury quite easily. Okay, so this is possible. Okay, yeah, this is possible. The other thing that we want to do is the anhydrous copper sulfate can also be used to test for water. Let me show you how it can be used to test for water. This is actually semi anhydrous copper sulfate. Actually, it's supposed to be white. Let me try to heat it until it becomes white. Maybe it's not so easy for it to become white. Bring your QA book. Did you bring your QA book?
Yes.
Huh?
Yeah.
Yeah, bring your QA book. All right. Okay. You think you can turn to the page where you have test for water under the test for gases. Test for water.
Okay.
Yeah, okay. Some more, one more page. Okay? Okay. That page is fine. Now that page there, the test for water, we actually have the anhydrous copper sulfate. Actually, this part will be better. Hey. Oh, try to heat this. Heat this, yeah. Let me check, Stir it around, move the flame around. Okay.
Why does it sometimes look like green or something?
Yeah, because it's got some other problem. Now what we have here on this page is we heat blue hydrated copper sulfate here and it turns white. Okay? Keep on doing. And then we take the anhydrous, white anhydrous copper sulfate. We added water and I think this was turpentine or some organic liquid. No, this was turpentine and this is water. When you add water to this, keep on, yeah. When you add water to this, it will turn deep blue like that, okay? Because the hydrated copper sulfate will come back. But if you add a liquid which is not water, then you will not turn blue. You will just get a wet part or a wetted part. So what we are going to do now is we are almost getting the anhydrous copper sulfate right, huh? Almost, okay? Yeah, copper flame seems to give you a greenish blue this.
Yeah.
Okay, this is quite good. This is not bad really. Okay, let's see, let's turn the flame off. Now we are going to add all this. We are going to add a little bit of water onto this anhydrous copper sulfate. If I add a little bit of water, you see here on the right of the camera, it turns blue, right?
Yeah.
And you see it turns real blue. But if you were to add pure alcohol, this is pure alcohol, you'll find that the pure alcohol will only give you a wet patch, but it doesn't turn blue. So why anhydrous copper sulfate can be used to test for water? This is not water, so this cannot turn blue. Can you see? Alcohol is dripping in, but it doesn't turn blue. Because it is not water, it cannot be incorporated into crystalline blue hydrated copper sulfate. But this one is hydrated copper sulfate. So anhydrous copper sulfate, apart from blue cobalt colloid paper, is used to test for water like that. Can you see? This one is alcohol or turpentine or CuSO4 organic liquid, but this is water. Yeah. Good. Yeah, that's not bad. Although we cannot get this to be as white as this. When I wrote this book, we were able to get the anhydrous copper sulfate to be white like this. Well, this is almost white anyway. Okay lah.